And we've talked about, in order to say that we have a two-sided limit, that we have to have the left and right hand limit equal to each other. So when we're looking at this piecewise function at x equals 4, we need to look at the left and the right separately, because 4 is the breaking point. They go to different things. So we need to do the limit as x approaches 4 from the left of our function, and the limit as x approaches 4 from the right. And if the limit exists, these two numbers will come out to be the same thing. Alright, so if you are approaching from the left, that means you have things smaller than 4. So which piece would you be on? The first or the second? The second. Because you're less than 4. Okay, and that's a polynomial. So we said yesterday you can just plug it in. At this point, whether it's from the 4 from the left or the right, you can just put your 4 in. Once you plug it in, that's when that limit symbol goes away. So you get 8 minus 8, which is 0. If we approach from the right, which piece are we on? The top, because it's bigger than 4. Okay. We had a limit law that said you can bring your limit under radicals. So if we plug in, we get the square root of 4 minus 4. Square root of 0 is 0. So does this limit exist?
Yes.
Yes. So that means the overall limit as you approach 4 also equals 0. Let's take a look at another. Do you guys remember what this means?
The greatest integer of any.
Yeah. Let's look at the graph on that. That might help us. So remember, the greatest integer is you only get out integer values, and it can't be bigger than what you plugged in. So if I put in 0, 0 is an integer, and I get out 0. If I put in like 0.5, 0.5 falls between 0 and 1, you have to give me the smaller one. So you're still getting out 0. If you put in 0.9, what are you going to get out? 0. But what happens if you put in 1? You get 1. So remember, that was like the stairs. You'd have an open circle underneath. And those just keep going both ways. So if I want the limit as I approach 3, let's look at the left and the right separately. As you approach 3 from the left, if you're putting in something smaller than 3, so like 2.5, 2.9, 2.99, what are you going to get out? 2. Think about it here. If you're approaching 3, you're right here on this step, so you're getting out 2. But if you approach 3 from the right, you have things bigger than 3. So we're approaching 3, but this time I'm up here on this step. What are you getting out? 3. So what does that tell me about the limit? The left and right hand limits exist, but the two-sided limit does not. Alright. We really just have one piece left to talk about today. So we have a few theorems. It tells us if you have two functions, f and g, and f is always less than or equal to g, except possibly at point A, because remember, a limit doesn't care what happens at the point, just as you get close to it. So if your function, if f is always smaller, then the limit is always going to be smaller. Okay? That allows us to use what's called the squeeze theorem. So sometimes we get some nasty functions that we can't use our limit laws to do the limits of. But if you know that function falls between two other functions, then if you could do the limits of those and they're equal, that means the middle one has to be equal as well. Think about it in terms of a graph. Okay, here is H is my green, G is my pink, F is my blue. Can you guys agree that at least close to this point A, G is always between H and F? Right? So even if I can't find the limit of G itself, if I can find the limits of H and F at point A, if those are the same, then the middle one has to be the same. Now there are several different places where this is applied, but we are going to keep it really simple, and all of our problems are always going to be very similar. I'm going to use this with trig functions when we do it. So we're only going to look at it with a sine or a cosine when we do this. So let's take a look at this example. I've already told you the limit is going to equal 0. We have to show why that's true. So we do not have a limit law that allows us to just plug in, plug into a trig function. And even if I wanted to, can you do 1 divided by 0? No, so I can't plug in there. We have to start with something we know. So let's just think for a minute about sine. If you're talking about the graph of sine, what does it always fall between? Think about your unit circle. Sine is your y. What's your highest y value? 1. What's your lowest value? Negative. That's why we're going to use this with sine and cosine, because we know both of those fall between 1 and negative 1. Okay, so I'm going to walk you through an example, and then you guys are going to try one like it. What we need to do at this point is create this piece from here. Right? So starting with the first difference is this angle. Now, if I change my angle, does that change my highest and lowest point? No, it changes the period, but it doesn't change your highest and lowest. So we can then say, well, that means sine of 1 over x is also between negative 1 and 1. Okay, so now I've got this sine of 1 over x, so the next piece I need is x squared. Now if you square something, it's always positive, right? So could I just multiply everything by x squared here? But if I want to do it to the middle, I have to do it to the ends as well. So that means negative x squared is less than or equal to x squared sine of 1 over x is less than or equal to x squared. So I'm creating the function I want. Okay, I still can't do the limit of the middle, but can we do the limits of the ends? Yeah. So now, the next piece I'm going to add in is my limit, and we're going to do it on all of them. So I have the limit as x approaches 0 of negative x squared, which has to be less than or equal to the limit as x approaches 0 of x squared sine of 1 over x is less than or equal to the limit as x approaches 0 of x squared. Okay, still don't know how to do the limit of the middle, so I'm not going to be able to get that one. But the ends, we can. What do we have to do? You just have a negative x squared, can we plug in? Yeah, so the opposite of 0 squared is 0. If I plug in 0 here, 0 squared is 0. So if this falls between 0 and 0, it tells me it has to equal 0. And we just showed that. I would like to do at least one more of these. I think I might have a couple on here, but I want you guys to try one on your own, and if we're okay with that, then we may not do the last one. So why don't you guys try setting up this one, see how far you get. So when I see either a sine or a cosine, I know that's between -1 and 1. Then change your angle to match what we need, because changing the angle doesn't change the high and low points. Then we need the x squared, so if I take everything times x squared, and then what do we need to add in? The limit. So we have the limit as x approaches 0, negative x squared. It's a lot of writing. So both of these go to 0. So this limit is 0. Alright, like I said, there are other applications for this, but we are going to keep it very simplistic. We're just going to stick with sines and cosines. So it'll always start out the same way, between -1 and 1, and then just manipulate that. Okay, do we need another one of those? So here's what we need to do. I just posted a handout on Classroom. So that's more practice with these limit laws. There is also a book assignment. If you're looking at your notes handout, you're probably wondering about that. So today's assignment, this is Thursday. We have the handout. If you finish that and want to start the book problems, you can. We won't be in class tomorrow. Monday will be a work day for the book problems. So if you get done